Whoa! Hey, hello. You must be interested in the title of this video. Oh, okay. You probably want me to explain what it said. Okay, gotcha. So, yeah, today we're going to be covering an overview of what is Cisco Layer 3 switching, how does it work, things like that. I'm Zakamo, otherwise known as Zach Downing. I have references provided below for all the information I'm going to be talking about in this video. Please correct me if anything I say is wrong, or you just don't like how I'm talking, or maybe you just don't like me and you just want to punch me in the face. Let me know. Leave a comment below. I'd love to hear some feedback. So I just want to first start off with what is layer 3 switching at its core. Well, it's when a router receives a packet and it looks at the IP header for its destination, and it looks in its routing tables and all the information it has about the metrics and everything, and then points that packet where it needs to go and sends it on its way. That's the essential function of layer 3 switching. So where does this process actually occur? Specifically, Cisco Express forwarding. Well, Cisco Express forwarding runs on any Cisco iOS router or layer 3 capable switch, and specifically not switches that are running Nexus OS. They run a slight variation of Cisco Express forwarding, but I'm not going to be diving into that today. Why do we use Cisco Express forwarding and not something else like process switching? Maybe you've heard of that before. Well, basically, it's for efficiency. Cisco Express forwarding is just a lot faster, and it doesn't have to wait on individual CPU cycles to process each individual packet. So now I'm just going to kind of walk through the overall flow of how Cisco Express forwarding works and what the individual components of it are, and more importantly, why they are and how they are as well. So when a router receives a packet, first of all, it's going to check the forwarding information base, otherwise known as the FIB, for reachability, making sure that it can actually send the packet to its next destination, or at least its next hop, where that next hop will know its destination or know someone else who knows its destination. And then it has to make a decision on prefix specificity, otherwise known as finding the longest subnet mask match. It then checks the adjacency table. The adjacency table is how a router defines what is adjacent to it. So in this diagram you can see here on router 1, it has adjacencies with R2 and R3. And if you've been studying networking for a while, you may think of an adjacency as like a OSPF neighbor or a EIGRP adjacency, something of that nature. Well, most of the time those are adjacencies, but they don't necessarily have to be actually adjacent, especially with like BGP neighborships. Those are especially not always adjacent. And so, for example, we can actually look at this adjacency on Cisco iOS. If I look at this R1 here, and we'll just do the command show adjacency. And we can see here that on gigabit 02, it's connected to a device that has an IP address of 10.0.12.2. And that is the interface where R2 is connecting to it. And we can see that. I'm going to verify that again with the show CDP neighbor, as you've probably done before. And we can see that R2 is the local interface on R1 is gig 02, and it is connected to gig 01 on R2. And here is a diagram of what this actual topology looks like. And so it uses the adjacency table to find the source and destination MAC address info to then replace the Ethernet header information so it can actually be properly switched via layer 2. So when it actually reaches a switch at some point, the switch actually knows what interface to actually send that out to get to the host once it actually gets to its final destination network. And then it also uses the adjacency information to find its next hop, because the next hop is going to be out of a directly connected interface, of course. I mean, how else can it, how else can it send it out? It's got to be directly connected. So So after that happens, it has to actually replace the source and destination MAC address and forward it out the next hop interface. So let's just back up a little bit here and talk about the FIB, or the forwarding information base. What is the FIB? Well, it contains a mirror image of the routing table along with adjacencies. And as we discussed before, the adjacencies are devices that are going to be directly connected with a single layer 2 hop. And you can actually see this forwarding information base with the command show IPCEF. And so we can see here there are networks in here like we would be able to get from their routing table, like 10.0.12.0/30, which is directly attached. And so it shows attached there for the next hop, and the interface where that network is actually on. And you can see here there's also routes for loopbacks, like we have here. We have the loopback 0 on each of these routers with their 1.1.1.1 if it's router 1, and then same for router 2 and router 3. And we have OSPF neighborships between all these routers, so they know these loopback information. And so with the routes, we have the next hop 10.0.12.2 to get to 2, and then same for 3. Well, what are these next hops, attached and receive? What do they actually mean? I just want to kind of wrap it up in a nice little bow as to what you can actually identify these as. First of all, attached. Attached is always going to be a subnet and a directly attached host or an adjacency. And so we see that with 10.0.12.2/32 as attached. That's actually router 2, and it knows that. It knows these adjacencies from the ARP table, or rather the ARP cache. And what we see with receive is the specific network ID with a /32 along with its actual interface, its actual local interface. So where does it specifically get this network information and the next hop addresses? Well, it technically doesn't get it from the IP routing table. It gets it from the routing information base, which is pretty much the same thing as the routing table. And the routing information base, or the RIB, is basically just a collection of routing information from all the different dynamic routing protocols along with static routes. And you can see this with show IP route. It's basically the same thing. I think there's just a slight difference in terminology and maybe the formatting there on what you actually see with the show IP route. So yeah, that's Cisco Express forwarding in a nutshell. You have the forwarding information base and adjacency, where the forwarding information base is built from the routing information base along with the adjacency table, where it then uses the routing information base to make sure it can actually reach the destination or reach someone that might know the destination, along with matching the most specific route it has for it. And then using the adjacency table to then pick what interface it's going to then send that packet out of, along with finding its source and destination MAC address to then switch the Ethernet header. Thank you for watching, and please let me know how you liked it in the comments below.